As a reminder, we have a quiz on Thursday with 8.4, so tomorrow we'll review for the quiz. Thursday's the quiz, okay? Albert I.O. is open Monday to Monday, and homework check tomorrow. So be ready. Have D1 up through yesterday completed. So D1 through D5. You know I'm checking D1, which was when I had the sub. I already told you I was going to do that one, and then I'm going to pick one other one. So just be organized and all that stuff, okay? I think that's everything. Quiz, homework check, Albert I.O. Okay, yeah. Yes. Where? Here? Natural logs, just like yesterday. Same thing, natural logs. And remember, natural logs are ln. ln. You know, Shane was judging my handwriting yesterday. I'm just kidding. But you can write ln, I mean, however you want to write it, okay? It means natural log. What's the base of all natural logs? E, which is a number, okay? It's just like a placeholder for that 2.7 blah, 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 big old number. But it is a number, but it's always that. So we have 3 different types. I guess 2 different types of equations here to solve. I see some of you still writing, and I want you guys to be able to follow along. So catch up. I can have everyone's attention. Yeah. Oh, what? Yeah. All right. So the first example here, when we have an exponential function. This is e to the x. Anytime you see an exponent with a variable in it, that's called an exponential function, okay? So that's what that is. And to solve for x, we're going to first get the e by itself, okay? That's our goal. We need to get rid of this plus 2 in this multiplying by 4. So we've done this before in other types of problems where we clean up the problem a little bit. I would subtract 2 from both sides. And then divide by 4. My goal is to get that e by itself.
It's 13. 15 minus 2 is 13.
13, sure is. Thank you. Thank you. 13 over 4. Thanks. E to the x equals 13 fourths. And let's see, if I put 13 fourths in my calculator, 13 by 4, yeah, you could write it like that, or you could use the 3.25, which is probably better. I'm going to go ahead and change it to 3.25. Remember, you can always change something to it. You can always use the decimal version of something if it terminates, okay, meaning it doesn't keep on going. You don't have to use like a repeating symbol. So you could use the fraction or the decimal in this case. All right. Now remember, that was just the cleanup part of it. We were just getting the base e by itself, okay? Now we have to solve for x. That's what we do with equations, right? We solve for the variable. So we need to know what x is. And we had these same types of problems on the test on Friday, where there was a number here, like 2 to the x. And how we got the x down was we took the log of both sides. We gave both sides a log, which then allowed us to bring the exponent down. Well, we're going to do the same thing. The only difference is that since this is an e instead of a number, we're going to use natural log. So I'm going to give both sides a natural log. It's keeping my equation balanced. And whenever you do this, now that we're at a log equation, the x can come down on the ground. Remember, our goal is to get x by itself. So this is multiplication, but there's something kind of special here that if you catch it, it makes the problem one step easier, and that is natural log e equals 1. This right here equals 1. Maybe you want to put it up here. Here's why. Because remember, whenever you have a log in a number here and the base, whenever these are the same, that equals 1. So when you see natural log e, we know all the time that natural logs have a base e. So anytime these two are the same like that, the whole thing cancels out and becomes 1. So really, all you have left is x equals natural log of 3.25. We can just put that in our calculator and get the answer. A lot of people are going to forget that, and they're going to go ahead and divide both sides by natural log e, which is totally fine. You're basically just dividing by 1, which is not going to change your answer. Okay? So your natural log button is right below your log button. So if you put in natural log 3.25, and I'm going to put it in my calculator with all of this, and I'll prove to you it's the same thing. Close your parentheses. Remember, we talked about that a lot on the last test. Don't forget to close your parentheses. Divided by natural log e. Now, e, look at my pen, is above the division symbol. So since it's above the division symbol, it's in blue. I have to hit the second button. See why you don't even want to have to do that? Because that equals 1. Natural log e equals 1. And we get 1.1787. Rounding to the nearest 10 thousandths, just like we did on the last test, is 4 decimal places. But if I had just put in, guys, natural log 3.25, I would have had the same answer. Because natural log e is just 1. So you can just cancel that out if you'd like to. Okay, I'll show you that again in a different problem, and that's our final answer. Okay, now what's different in these other two problems, these are same kinds of problems, is that they have natural log already in them. These are not exponential equations, they're log equations. And what we're going to do is rewrite it in its other form. As we talked about yesterday and today, the base of a natural log is e. There's an e there. So what we're going to do is rewrite it in its other form. And we learned how to do this yesterday, or really just practiced it. It's always a base e, powers on the other side equals the x plus 2. And then we just put the rest of it in our calculator. E to the third power. Guys, look above the natural log button. Look above the natural log button. It has e to the power of x. That's what you're going to use. Second, e to the x, and then I'll put in the 3. So that's e to the third power. Again, everybody look, so you know where it is. It's above the natural log button. E to the power of x. So that would be and then subtract 2. Okay, so again, when the word log, when it's a log equation, meaning the log is in the problem already, that's when you rewrite it in its other form. Okay, we're going to do that again here. When it's an exponential function, you isolate the e and then take the natural log of both sides. When I say take the natural log of both sides, that means give both sides the natural log. Okay? Okay, here again is just like this one. We have a base e. You'll never see it written there. We just know that natural log is an e there. Never will it be anything else, ever, ever, ever. So it's e to the 5th equals 2x, meaning e to the 5th equals 2x. So, again, e to the power of x is above the natural log button. Know where it is now. E to the 5th. That gets me 148.4132, right? A 5 tells the 1 to go up to a 2. But we're not done because we still have to divide by 2. We'll actually do our final rounding in the end right here. Divide by 2. Okay, so basically 2 types of problems. Rounding matters. Okay. So we have the assignment written down. We're going to go to page 88, and I'm going to do a whole bunch here at the beginning with you, like the first 2 or 3 with you. Okay? So get out your page 88. It's on the back of yesterday's page. And let's do some together. Okay, so again, there's only 2 types of equations. You're either a log equation, that means you have log in the problem already, or you're an exponential. It's one or the other. This is an exponential function. We are going to just isolate the e first. You have to get the e to the x by itself first. That means we have to subtract 3, divide by 5. It's on the back of yesterday's paper. So if you Oh, I know what happened. Well, I'm going to be putting it up. When I'm done with this part, I'll let you guys take a picture of it if you want to. But I'm going to do some with you anyway. All right, so 18 minus 3 is 15. Divide by 5. Okay, I'll slow down. I hear a lot of paper rustling. And so remember, when it's an exponential function like 29 is, we clean up the problem to get the e to its power by itself, which we did. And once we do that, think about what you're trying to do. You're trying to solve for x, but x is up in the air. It's an exponent. So what we do is take the natural log of both sides. We use natural log because it's a base e. And you can do anything you want to an equation as long as you do it to both sides. And why we do that is because now you can use your properties of logs. That says, if you are a log, you can apply the properties. And we have a power property that says exponents can also be written down in front. And what's nice about these problems is every single time you're going to end up with a natural log e. Natural log e equals what? 1. So you just can kind of cancel out. It's just 1x. That's basically what that is. 1x. So all you have to put in your calculator is natural log 3 to get your final answer. And rounding to 4 decimal places. What's different about 31 from 29? What's different? What'd you say, Shane? I just couldn't hear you. You might have been right. No? Nobody knows? What's different? There's no cleanup to do. The e to the x is already by itself. We don't have to do those first beginning steps. Since the e to the x is already by itself on one side, we can just go right to the step where we take the natural log of both sides. This one was easier than the other one. Natural log e is just 1, so all we have to do is put natural log 5.8 right in our calculator. Does 33 have any cleanup in it? Yeah. The answer is yes if there's anything on the same side as the E. Okay, that 4 has to go. How am I going to move it? Sarah, you seem to be on a roll. How am I going to move it? Minus. How do I know it's not multiplication? Because it's not right up against the E, okay? Like the 5 here, that would have been division to get it to the other side. But see how it's separated? That's subtract. Now that the E is by itself, we take the natural log of both sides. Now that it's a log, we can bring the x down. That's 1. We'll put that in our calculator. I'm actually going to do one more with you because I want to do one of the log ones with you. 34 is the next one. So pay attention to what's different in this problem, number 34, in comparison to the 3 we did before it. 29, 31, and 33 were exponential functions. They had e to the x in them. 34 doesn't have an exponent anywhere in it. It has a log in it. Okay, that's what's different. When it's a log equation, we have to rewrite it in its other form, exponential form. It's kind of ironic. We start out with exponential form, we turn it into a log. We start out with log, we turn it into exponential. So the base of our natural log, we always know it. You'll never see it written there, although I wouldn't mark it wrong if you did it, is e. So it's e to the first equals x minus 6. Now remember, e is a number. And it's a button on your calculator. It's above your natural log, e to the x. It's blue, so you have to use the second button. Second, e to the power of 1, enter. And then we need to get x by itself. Are we starting to get it, guys? Just 2 types of elements. I left you 3 to do. 3. These are the answers, obviously not the work. When I check homework, guys, I'm going to be more strict about you guys showing work. You cannot just write answers.